My career has been littered with modernizing legacy applications where the cost of maintaining the code exceeds the cost of replacing the code.
Welcome, everybody, to Continuous Delivery Office Hours, where we delve into the topic of modern software delivery. I am your host, Tony Kelly, and I'm joined by Steve Fenton and Bob Walker. Topic for this week is modernizing legacy applications. And I suspect the word legacy comes with some connotations, and some people may think legacy is bad. What comes to my mind as an analogy is like, oh, you've got a Sega Mega Drive. I've got the latest PlayStation. It's like, oh, Sega. That's not really the case. It's I think they get labeled unfairly, but I will pass it over to you, Bob, if you don't mind, and sort of give us an idea of how you interpret legacy applications and what they mean.
Did you know there's a whole market out there for vintage video game systems? So as soon as you said Sega Mega Drive, I'm like, oh yeah, there's a there's YouTube channels on YouTube channels that's like that's all they want to talk about. So yeah, so when it comes to legacy applications, yeah, they do get a kind of a negative connotation attached to it because the term legacy means that it's old, it's unusable. But truth be told, a lot of times these are the applications that are running in the background that are keeping the business running. It's the thing that's been battle tested. It's the thing that's continuously working and it performs a very critical function for the organization. This is why I don't really like the term legacy, but we're going to continue to use it for the rest of this conversation because it's a lot easier and it's probably better for the SEO and the searching because people are going to search on that. I prefer the term heritage application because it's still a very important application that's out there that the business itself needs to run. I think the challenge typically happens with these older applications is that they've been working and people know that they've been working and there's not probably a lot of investment into improving them because they just do their job and they do their job extremely well. And then you don't really think about it until there's some sort of inciting incident, either like the host operating system is out of support, or the vendor contract expires, or the company that's providing some sort of third party library goes out of business. Any sort of those big inciting incidents, like, oh, we need to really start thinking about this application now.
Yeah, and I think that's one of the crucial things about these applications are old because they worked, right? If they weren't successful, they would have been thrown away a long time ago, but they're being kept around because they've been battered by reality. The application that was built on day one, what's happened is thousands and thousands of days of little changes to just make it work as the business needs. So there are like layers upon layers of knowledge kind of baked in and hidden inside of that application. And that makes it superbly valuable. And it makes modernizing it quite hazardous, I suppose, as well.
It's funny when we talk about legacy applications like that and that they have been working and they've been working for quite some time. A really old example, but I would still want to bring it up, is Netscape Navigator. It had been built over the years and it had been working as a really good browser engine, but there were problems with it. And the team made the disastrous decision that they're going to completely rewrite it for Netscape 5. It ended up being a total disaster because they lost all of that kind of institutional knowledge that was built into the code base and they're relearning the same lessons over and over and over again. And it ended up delaying them more and more. And so much so that Microsoft came in and basically won that first generation of the browser wars with Internet Explorer because of that disastrous decision.
Yeah, I remember reading about that. And the interesting thing is they had something that it mostly worked. Sure, it had problems. But then when they decided to do the huge rewrite, most of the work that they did for the next year, 2 years, was replicating what they already had. It was almost like they were ignoring the value that they'd already built up. And so actually, for a large amount of that time, they weren't really adding real value to their company, and they weren't adding any value to their users because they hadn't released it, right? So it was effectively like they'd stopped work. That's what it looked like to the outside world. I think that's actually probably one of the great risks is I get this feeling whenever I join a team and I look at the code, there's definitely an urge to want to rewrite it. Right? It's just natural. There are parts that just aren't tidy or don't make sense, or that are really hard to understand. And I definitely feel that instinct. I want to rewrite this. And so part of this problem is being super careful about what stuff we think we need to rewrite, and when.
I suppose another question to add into that. So, why do we need to modernize legacy applications? It sounds like they're valuable, they're working. What's the driving factor?
Not every application that's legacy should be modernized or should be rewritten in that sense. Oftentimes, it's a case of when we're gonna have what can we do in that particular case? And I'll be honest, not every legacy application needs to go through that updating process. Oftentimes, it just needs to be replaced with something, I wouldn't say something better, but something different that solves a particular problem. Because oftentimes, and I've seen this happen firsthand, in fact, my career has been littered with modernizing legacy applications where the cost of maintaining the code exceeds the cost of replacing the code. And we've kind of reached that point of like, okay, no one understands it, no one can work on it, and okay, now we need to come up with an approach to replace it. But it shouldn't be a like for like replacement. And I think that's the thing that we saw with the Netscape browsers. They basically tried to replace it like for like, and then start adding on top of it. Whereas really, it's a case of we need to rethink how this is going to work, because as good as it is to have those legacy applications, and as well as that they've the problems that they've solved, they still also reflect the company as it was 10, 15, 20 years ago. And as the company has evolved, you kind of have this legacy application that's kind of dragging you down, so to speak. I think of a person that's trying to, say, push a big old cart up the hill that's full of all of this stuff. If you can make the cart lighter by replacing it with better pieces, then overall it's going to be better.
Are there industries that are more likely to have larger numbers of legacy applications?
I don't know if it's universal, but I almost want to say it's almost directly correlated to the age of the company. The older the company, the longer that's been around, the higher likelihood that it does in fact have a legacy application or two or 20 or 100 running in the background. Yes, especially the ones that grew up, so to speak, I would say in the 70s and 80s, more likely than not have those legacy applications running in the background somewhere.
Yeah, and I think there are probably industries where companies do tend to last longer. Thinking of the finance industry, a bank or a financial institution, they tend to be a long-term company rather than, maybe a company that's got a product that's maybe great at a certain point in time, but then competitors overtake it, or what people need changes, and they kind of like wrap up and retire that kind of software, maybe even the whole company. So yeah, longevity is definitely the measure, and there are some industries that do tend to be around for a long time.
It's probably the companies that tend to be a bit more risk adverse, and it's not because they're risk adverse because they're uh, slow or methodical. It's when the risk of something going wrong, when that thing goes wrong, that thing that happens has a significant impact either on like the economy or people's lives or the health and welfare of people. So generally it can typically, I would expect to see more healthcare or like you said, finance. I could also see manufacturing as another really good example of something going, where you're being a bit more risk adverse because again, you don't want to have recalls. You don't want to hurt people. That's a bad thing. So I typically would see something like I would expect to see something like that as well.
How would an organization or teams approach a process around modernization at a practical level? What would that look like?
Yeah, so the way that I've always looked at it is by starting with the team design first. If you imagine a really small company where maybe you've got one team of developers, I'm usually looking at how do I split now into two teams of developers? And when we do that, how do we make the architecture follow that split so that those two teams can work independently of each other? That basically means that you're keeping the complexity for each team reasonably low. So fewer dependencies keeps complexity low, and just the ability to work more autonomously. More recently, team topologies has been a really useful toolkit for doing that. I didn't have that earlier on in my career, But when it arrived, it just had a really useful language for describing different team types, different interaction modes. It really helps with that way of arranging your teams and architecture, because Conway's law says that the way we design our communication systems between people is going to be reflected in the architectures that we build. So that's how I would approach it. First of all, I'd start off by looking at team design.
I'm thinking through all of the rewrites that I've been involved with where we modernized a particular application. And sometimes we did think about team design and sometimes we didn't think about team design. And I'm thinking through the successful ones versus the non-successful runs. And generally for me, what worked out was we kind of approached it with like a strangler fig approach, which was we have this functionality that exists in this legacy application. And generally it's a lot of functionality and it's performing a very that's performing so many different tasks. 'Cause oftentimes that's probably a monolith, and I've seen that quite frequently. And so typically, what I've seen is people taking like carving out a piece of the functionality. For example, like I worked on a loan origination system at a bank, and that's pretty simple for people to kind of understand. So I like to use this as an example because a loan origination system, well, you're going to probably check the person's credit. You're going to have to store the person's personal information someplace. You're going to probably have to store their financial information, like their tax information, and you're probably going to make a decision. And so previously, all of that was all encompassed in, say, one particular application. And if you wanted to make one change to a component, it was always a big problem. And so you start carving out pieces of functionality. Could we have a credit service instead of the credit check occur within the application itself? Okay, let's try that. Let's carve out that. Okay, do we need to have the customer information stored inside of this, or could we have a separate application for there? So it's kind of like looking at it at the application, almost like the architecture, and then starting to carve out those bits and pieces until you're almost left with nothing. Now, the challenge with that is always going to be the interface because that legacy application still needs to run because it's still going to be performing those tasks. So you're going to still have to update that legacy application to either have some sort of shim in your code base that basically says, okay, call out to the service, for example, instead of performing the task itself. So you're almost deleting the code, or you're going to have something that interacts or calls the legacy application to say change its state to say, hey, we've already done the credit check, or we've already gathered the financials, or something along those lines that essentially tricks the application into saying, oh, I can move on to the next bit and piece. And I would say that's probably the thing that's going to cause the most consternation and the highest risk is that interface layer. But it's interesting when you brought up the team size because or the team dynamics, because then it's kind of like as you carve out those pieces, then you can hand it off to a group of developers or a group of a team itself. And sometimes I saw that happen where you handed it off to a team that did it, but other times it was just a big development team that you kind of carved up into smaller sub teams. So you still had just one manager because of reasons. And that tends to work as well. But you do need to have like a dedicated group of people working on that new functionality and having them take ownership of that. I think that's probably the biggest key, if anything.
Yeah, that makes sense. I think the crucial thing is that you don't want to end up with like lots and lots of services that you split out, but a single team managing all of them, because you aren't getting necessarily all of the benefits. And you don't want it the other way either. You kind of don't want hundreds of teams all contributing to the same chunk of code, because then they're all tripping over each other and you're going to get merge conflicts. It gets a lot harder. So yeah, there's just benefits to thinking about the two things together. And the Strangler Fig's a great way of identifying an area that can be moved out, with some people to maintain that and develop it. And in some cases, you might move a service out, like a loan calculator. That when it works, right? You don't need to update that anymore because the way you calculate the effect of interest over time is mathematical and kind of fixed. So there might be some things you split out and you don't even need to put a team on it, but you'll still need to do some maintenance tasks, maybe update dependencies and things like that.
You might reach a point within that strangler fig pattern where you have strangled that application as much as you possibly can. And there still might be a piece of functionality that you just have to leave in there for a whole host of reasons. It might be you might not have that third party library anymore. And it's mission critical that you have that third party library still interact with whatever reason. Um, give you a really concrete example. The loan origination system that I worked on was actually V3 of a loan origination system. V1 was a desktop application that ran on all of the employees' desktops and all their work computers. And the final thing that this desktop application did was it generated the actual documents for the person to sign, and it would go through Word templates and do all of that. We looked at every possible way to kind of replace that, and at the end of the day, it's just like it just didn't make sense to replace that completely. And we said, all right, let's come up with a service layer that basically injects the data into the centralized database that these desktop applications pull from, and then we call it good. And then from there, it can generate whatever documents we need to generate from there. And it's a bit of a pain, but at the end of the day, it was the most sensible decision because the cost of replacing that particular aspect and going through all of that was significantly higher than maintaining that particular aspect of the application. So we had strangle figged everything except the document generation out of that original application, but we still needed it at some point. So I thought that was rather interesting because it is going to be a business decision at the end of the day. You need to have an investment to do this rewrite to modernize the application, and you will reach that point. You might reach that point where, okay, we've done all we can do and we're in a really good state, but there's still some back end stuff that still lives there.
Cool, very good. Steve, I think it's that time. What is question of the week?
Yeah. So, question of the week this week is I want to hear your most challenging modernization story. Like, was it a particularly gnarly app, or were there just stumbling blocks you didn't expect? And how did you make it successful?
So I worked on an application where the vast majority of the business logic lived in Oracle packages. Are you familiar with Oracle packages at all?
I've never used them.
Oracle packages are a lot like stored procedures in an Oracle database, but on steroids. So they're almost, in a lot of ways, they're a lot like stored procedures, but you can also do things like call other packages and pass data to them. And it's a lot like having functionality built into your database. And it was just a spaghetti code mess inside of these Oracle packages. And we made the decision like, okay, we need to pull this logic out because that's so dangerous. Because every time we made an update, it was like a fingers crossed type of moment of, man, I hope this works. And very few people could maintain it. It was slow to run, which was kind of shocking because it was on the database itself. You wouldn't think it would be slow to run, but there were a lot of reasons. And so we made the decision that we were going to rewrite it in a .NET application. And the way that we made it successful was basically we spent probably a good 2 to 3 months just diagramming using Visio all of the workflows. Okay, I get a request here. What's all the decision tree that it's going to do? What's the decision tree to get to this particular point in time? So that was a big help. So I understood what the business rules were that I was trying to enforce. So that was step one. Step two was we came up with a very clear rule that whatever inputs that I send in, I should always result in the exact same outputs, regardless if I'm going through the old Oracle packages or the new .NET app. I couldn't fix problems. I couldn't fix bugs. So if a bug appeared, because I'm reading the business logic and I'm confirming with the product owner, it's like, should it work this way? And they go, yes, it should work that way. It's like, well, it's not working that way now in the Oracle packages. So I had to actually inject shims into my code base that replicated that bug if a particular condition occurred because of that rule. Because then when came time to roll it out, well, we could redirect traffic much easier because of that one particular rule. So we could say, okay, we're going to send 10% of our traffic to the new system and keep 90% on the old system. And because the responses were the exact same, it was extremely seamless in that. And then eventually, after we had redirected all the traffic to 100% and it stabilized, it had been live for several months, then they're like, okay, go back through and clean up all those shims and remove all the bug duplication, so to speak. So it was very much a very specific instance of, for our particular case, of replicating that functionality, but we were doing it for a very specific purpose. So that I would say that was probably the only way we could do that in terms of the modernization. But that doesn't work for every single modernization because there were other applications I worked on where that didn't work. There was no way that could have worked because we had fundamentally changed everything how it all worked out. So uh, it's really going to be dependent upon the architecture.
I think that's a crucial point. Actually, the approach you take is going to be highly contextual because you're going to look for some seam in the existing application where it's going to split out nicely, and sometimes that is going to be a chunk of the application and the data. Other times you're going to need an intermediate step, right? Where you actually maybe you split the application, but the database remains almost like the integration point until you get to a stage where you can have that new slice writing to its own database as well as the old one. And then you can update all of the references from the old application to make sure that they're asking for that data from the application before you then get rid of those tables. So there is this kind of, there's a bit of a long process involved in this because you need to sometimes have things running in two places so that you can gradually update many, many calls in an existing system.
In a lot of ways, it's a lot like the expand and contract pattern because you're almost expanding your code base and you're asking it to do two things instead of one thing, and for a temporary point in time. And I think that's perfectly okay because honestly, you are trying to rebuild the plane while you're flying it because the last thing you can do is, again, we were talking about Netscape earlier, is you can't go dark for 2 years or a year and then resurface and basically say, great, hey, we've duplicated everything that we've done previously. Awesome. But they're like, well, what about all of those bugs and the new feature requests that we kept asking about? It's like, oh, don't worry about that. We just decided not to work on those for 2 years. That's just not an acceptable answer. So you have to keep on flying the plane and keep on delivering functionality while you're doing this at the same time. And I think that's the other challenge, is that it's a zero sum game. And so you have to make this very concentrated effort for that.
I think on my side, living in the marketing world for most of my career and being involved with websites, similar-ish sort of theme, but it's like there's always that is in, hey, we're going to rebuild our site, and it's like in this new land, 6 months down, we can have the new thing and it's there, but it's 6 months. It's like, do we do nothing? And so I've had a few different instances where we go that path, and it's like we do the thing, everyone's squirreling away in the background. 6 months time comes, and it's like, oh, it's a big bang, it's launched, it's out there. I think that the better approach is like, what can we do this week, this month? What can we improve? Get it out, and that could be your homepage, and then you go to sort of the tier two pages and back through. So it's a similar kind of thing where you're sort of releasing value more frequently, and you can get feedback. Is it working? And you might be into the tier two pages, you're like, oh, these haven't landed quite as well. You're only a month deep in that project, but in the other world, you're 6 months in, you think you're done, it's fantastic. You launch it, it's like, oh, didn't land as well, and you've kind of not back to square one. But it's that's probably been the biggest challenges, sort of. And again, you'll have different opinions and different voices who want to do one way or the other. But I think it's, if you put it from a customer perspective, the sooner that you can get it in front of those folks and start to get real feedback is always going to be the best path.
In my experience, every single big bang rewrite that I know of has failed. So I was working in a company that did pensions, and they had a team of 4 people working on the legacy system. It was written in Delphi. They brought in an external company who already had a system that just needed to be tailored to deal with our particular product type. And they spent a year on this and ultimately never went live. The project completely failed, cost millions. And I just see that over and over again. When it's like a complete ground up rewrite, it's most likely to fail. Like, there may be some survivor stories out there, but on the whole, you can expect it to fail. Breaking it up, doing a small piece, working out how you can do this strangler fig pattern so that you can replace one piece with something that works and that people can see the progress on, is definitely the way. And it's what we did. Like, I was working with Tony on our website, and it was running on a homegrown web platform. And we wanted to move pieces of that out onto a different platform. So we kind of carved little chunks off and moved those to the new platform and let them prove themselves to gain the confidence to do the next piece. a lot of that was driven by some time pressure because it was the old platform was running things that were going to be coming out of support. But it was successful because we did it in pieces and we validated each step as we went.
You absolutely have to do it incrementally. The Big Bang release, I've I've been part of two. Uh, they they worked, but the first couple of months after that initial release of that Big Bang, so to speak, was it was tough. It was a lot of things you had to work through because even though you thought you got everything, truth be told, you didn't. You could write all the tests in the world, you can have all the QA people in the world, but the simple fact of the matter is it was different. Even if you do a complete rewrite of the Big Bang, and you've improved all these other things, it's probably going to be, unless you have replicated the user interface exactly and like for like functionality and all you've like kind of what I did with that old system, where it's the exact same response for the exact same inputs regardless of everything else. Unless it was like that, which is incredibly rare, you're going to change stuff. That's just natural. It's going to be a different user interface. It's going to be a different thing that people are going to interact with. You're going to move a lot of cheese, and so you definitely need to think through and have it be small incremental changes. And the nice thing about that is that likely when you do those small incremental changes, you probably have a fallback because you're like, okay, like for example, you picked out a web page. Well, you pushed it out there. Well, that didn't work. Okay, let's redirect back to the previous page because chances are it's probably still running. Let's just redirect that back. And so it's much easier to kind of fall back to the previous version.
Cool. Thank you both very much. Thank you, Bob. Thank you, Steve. Thank you for everyone else for listening in today. I hope you learned something new and interesting about modernizing legacy software. As always, if you enjoyed the episode, you can find us on YouTube or your audio podcast provider of choice. If you search for Continuous Delivery Office Hours, you'll find us there. And a reminder that we have a bunch of white papers, publications, books that you can find at octopus.com/publications that revolves around most of these topics that we talked about most weeks. But that's it. Happy deployments, and we will see you on the next one. Bye, everybody.
Bye-bye.
Bye.